Hi, today I'm going to show you how to use the Directed Graph Markup Language, DGML, to visualize runtime object graphs. So up till now, we've been looking at static analysis using the Generate Dependency Graph, and this tool is able to look at the code in your solution and look at what it figured out statically from the code, what the dependencies are in terms of calls and so on. When I was running this program, I developed it a while ago and I upgraded it, and I'm trying to figure out why it's not working, because when I run the game, when those pieces hit the floor, there's supposed to be a sound, and there's no sound. But I don't remember the code all that well, and I want to come in here and look at the graph and see if I can figure out where to even start in debugging this problem. So I look for the word play, and there must be a play sound type of thing. And I remember here now that there's a log that I can play back a whole game, but that's not what I want, so I skip over that. That's not what I want. Play sound. Alright, that one looks good. So there's this little helper class here that has a play sound method. Let's jump in there. Just double click right into the code, and I see that there's a player, which is a media element, and it's calling play. So let's put a breakpoint there. And I'm going to show you how to build a runtime object graph. I want to look at who is referencing this media element. Perhaps it's not hooked up to the WPF element tree. That's what I'm thinking in terms of debugging why this isn't playing any sound. Now, in order to get a runtime object graph, I need to change the project properties to enable unmanaged code debugging. That's off by default, and you want to turn that on. So we'll save that, hit F5, wait for it to come up, start the game. And here we are at that breakpoint where it's supposed to play a sound. Alright, why is it not playing? Okay, so let's build the runtime object graph. So there's these fantastic tools that come with the .NET framework that extends the debugger. The tool is called SOS. Yes, you need some help? Use SOS. Alright, so I'm going to load that debugger extension. Now you can only load this extension when you're running in mixed mode debugging. That's why I had to turn that on. Okay, extension loaded. And there's a really cool dump heap command, because the manage debugger, if I look at these local variables, doesn't tell me what the actual memory address of that object is. Okay, so we need to find this player object in the heap. Would be nice in the future if we make that a little easier for you, but let's do a dump heap, and what you have to do is you have to provide the type of object that you're looking for, otherwise you get the entire heap, which is a little bit overwhelming. And in the debugger we can copy that type name, put it here. This will show us all instances of that object that are on the heap. This is a very small program, which is why this is so fast. In a larger application, you may have to wait a little while for it to grok the entire heap. And I can see anyway that there are 3 instances of that type at different addresses. I'm going to grab the last one. And now I'm going to do the real magic, which is another SOS command called GCRoot. So I'm just connecting the dots here. This guy will save your life. But it dumps out this fairly low-level log of object reference traces, starting at the root to the dispatcher, down through input manager, through some dictionaries, to the window, to media elements. So these little arrows mean that there's an object reference there. But if I scroll up, you can see that that's a lot of information for me to understand textually. So that's where the directed graph documents come to the rescue. I created a little tool, and I'll show you that right here, called GCRoots to DGML. If I create and all you have to do is pass in the GCRoot log, and it'll spit out the DGML. Well, let's create that GCRoot log. Just a text file, paste in the stuff we got from the GCRoot command, and we need to save that here, since that's where we're going to look for it. Yeah, I ran this once before, of course. And if I hit F5, that's it. That was pretty quick. Now we can load the DGML and visualize the object references that were produced by GCRoot. So GCRoot discovered this graph from the runtime heap object references. So this is fantastically useful, and in this case we're going to search for media element. And let's just see if there's any more. Oops, there's another one, which is the one we care about. 01C22. Back to the debugger. What did we ask for? That's the one we're interested in at the bottom of the graph. But as we saw, there's actually another one. And so why are there 2? And that really got me thinking in terms of debugging this. This one's hooked up to the dispatcher. It's higher up in the stack here. That's interesting. Why are there 2? And maybe that will help me debug this problem. If I do a search back in the code that I'm debugging, now kill that debugger. Let's do a search for media element. across the C# and XAML, just in case. Oh, and I see there's media elements all over the place. There's one here, there's one in XAML, and there's one that I was constructing, one in code. So we've got one in XAML and one in code, so that's got me thinking, well, maybe if I use this player, we'll be in better shape. So the play sound method, instead of using the player that we pass in, let's just do a quick cheat here and make a public static player. I had the code in here already because I don't want to waste your time watching me type. And in the constructor, instead of doing that, let's do that. So we're going to pass in the XAML declared media player instead of the dynamically created media player. And let's see if that makes a difference. F5, F2 to start the game. Now I can hear the sound. So that fixed the problem. And, so I used a combination of some static analysis to just look at, remind myself, how does this code work? Looking for, how the sounds work. I found that there's a play sound method used in multiple places across the program. I then used the mixed mode debugging and the GCRoot SOS command to produce a log file. I brought that over to my little tool so I could visualize what's going on. I found this runtime object graphs are actually quite easy to grok. Turns out there's a lot of null pointers at runtime, which makes these graphs actually a lot easier to deal with than the static analysis graphs. Okay, so there's one last thing I want to show you. I've been using this technique to also work on solving memory leaks, and that's a major reason why people use the GCRoot command. So I have another DGML graph that I created from some product code that I was developing, and I'll load that up. This graph is a lot bigger. You can see immediately there's a lot more nodes and a lot more links. And it was actually this object that I was debugging at the bottom, and I was able to trace back and jump over and see who was holding onto this. I could see there was a hyperlink object, and it had an event handler store. But I could also roll all the way up this graph into the VS Shell, and I could understand more about how my object was being hosted inside Visual Studio. And that was also very educational and very useful in terms of understanding things I had to watch out for. There was also a chain on the left here, and I was able to go that way. And similar sort of thing, event handlers, zooming, canvas, and so on. And this was my code. I was able to follow that chain all the way up the stack. I could see there was some dispatcher properties, and that was also part of the bug, was how the data binding engine works when it's bound directly to a CLR object. You have to be very careful doing that. There's some support articles that I found about that. So this was very useful. Another thing that was very interesting was when I switched to the quick cluster layout to get more of a force-directed look at this graph and zoom that to make it fit. Instantly I could see that there were some big loops in the object reference graph, which was very interesting, and this particular layout makes that really, really clear, which I liked. And let me show you a little feature while I'm at it. When you have a node in the graph and select it, you can also shift select, and what that will do is it will fill in the path from this object to this object. So if there are links connecting it, then it'll fill the path between them. Now, it also found that there were cycles. In other words, there was a path from this guy back to this guy, and it filled that path in for you. So that with just a simple shift click, I was able to confirm that, yes, indeed, these really are cycles that point all the way around in big circles. Whenever you have object reference graphs in a cycle like this, you have to be very careful, because if any one of those objects is going to live for a long time, perhaps it's rooted in the VS Shell or something, then this entire object graph will be kept alive. So now you have to think about, well, how can I break some of these connections so those objects can be garbage collected? So that was also very insightful. So I hope you enjoyed the demo of object reference graphs, visualizing with DGML.